Hi everyone, happy holidays. I am Sucheta Goet. Welcome to my session. I'll be talking about the essentials of Azure Storage, key concepts and best practices. Let's learn how to configure, manage, and leverage Azure Storage effectively to meet your workload needs. I'm delivering this session as part of the most festive event of the year, the Festive Tech Calendar 2024. Thanks to the organizers of the Festive Tech Calendar for consistently bringing insightful tech content from the community to support everyone's learning through the holiday season. So, explore all the valuable sessions as part of this event in December and stay ahead in your skilling journey. Check out festivetechcalendar.com. About myself, I'm a Microsoft MVP in Azure and security with over 17 years of experience working in large global enterprise IT environments. I currently work in healthcare IT in the US as the manager of an endpoint engineering team. I specialize in modern management and enterprise mobility, leveraging Azure and Microsoft Intune. I hold 15 certifications across various Microsoft Azure areas. I've shared my socials here. If you'd like to reach out for technical conversations, feel free. All right, the agenda. Azure Storage is essential for cloud-based workloads. And in this session, we'll start with an overview of Azure Storage, followed by an exploration of its essential concepts and best practices. We'll cover some of the key services, performance and redundancy options, security and access management, cost optimization strategies, monitoring and insights, and we'll conclude with effective automation techniques. Azure Storage offers much more than what I'll be covering here, so be sure to check out Microsoft Learn documentation for exploring it further. Okay, let's get started. Azure Storage is Microsoft's cloud-based solution designed for modern data storage needs. It provides highly available, scalable, durable, secure, and managed storage for various data types in the cloud. It supports multiple data services, including blob storage for unstructured data, file storage for managed file shares, queue storage for messaging, and table storage for NoSQL data. Azure Storage is a versatile solution that supports critical use cases such as application data storage, automated backups, disaster recovery, and long term archiving, enabling businesses to operate effectively, efficiently, and securely. To get started with Azure Storage, you would typically start with creating a storage account, which provides a unique namespace for your Azure Storage data. Data stored in Azure Storage can be accessed globally over HTTP or HTTPS using a REST API. Additionally, Azure offers client libraries for developers. The Azure Portal and Azure Storage Explorer are typically used for interacting with the Azure Storage Platform. However, you can also leverage Azure PowerShell or Azure CLI. Azure Storage offers a suite of core services designed to meet various storage needs for modern applications. These services provide scalability, durability, and accessibility for diverse data types and use cases. Let's start with Azure Blobs. It is a scalable object storage. Blobs is for massive amounts of unstructured data or binary data and text and image data. It is ideal for streaming audio and video, as well as storing data for backup and restore, disaster recovery, archive, and so on. Azure Blobs supports big data analytics via data lake storage, which is a powerful suite of capabilities built on top of blob storage. Data lake storage is not a standalone service or account type. Rather, it's a set of advanced features integrated with the blob storage service in your Azure Storage account. Next up is Azure Files. These are managed file shares for cloud or on-premises deployments, and these are ideal for shared drives. Then we have Azure Queues, which is a messaging store for reliable messaging between application components. Azure Tables. This is a NoSQL key value store for schema-less storage of structured data. Tables is ideal for web apps and apps requiring flexible data storage. Azure Managed Disks. These provide block-level storage volumes for Azure VMs, ideal for VM storage and database hosting. The next one here is Azure Elastic SAN. This is a fully integrated solution that simplifies deploying, scaling, managing, and configuring a SAN in Azure. Azure Container Storage is a volume management, deployment, and orchestration service built natively for containers. It simplifies storage orchestration for Kubernetes clusters. Each of these services we reviewed is accessed through a storage account. And additionally, Azure offers specialized storage called Azure NetApp Files. It is an enterprise-grade file storage provided by NetApp, supporting NFS, SMB, and dual protocol volumes for complex file-based applications. Azure NetApp Files is managed via NetApp accounts, and NetApp Files is ideal for databases, SAP workloads, and high-performance computing. So these are the core services which collectively address the diverse data storage and processing needs of modern applications, making Azure Storage a robust and versatile platform. Now let's dive into performance and redundancy in Azure Storage, which are critical features designed to meet diverse workload requirements while ensuring durability, availability, and optimal performance. Azure Storage provides two primary performance tiers tailored to different workloads, the standard tier and the premium tier. Standard is optimized for general purpose workloads with moderate performance needs and is backed by hard disk drives. Use cases include bulk data storage, archiving, or less frequently accessed workloads. Premium is optimized for low latency, high throughput workloads, and is backed by solid state drives, SSDs. Use cases of premium tier include transaction heavy applications, virtual machine disks, and high performance databases. Some Azure storage services offer either both or one of the standard and premium performance tiers, depending on workloads and use cases. For instance, Blob Storage offers both the standard and premium tiers, whereas Queues only offers the standard option. Now, Blob Storage additionally offers access tiers, hot, cool, cold, and archive, which are designed to store data cost effectively. We'll explore these tiers in more detail later in the presentation when we dive into cost optimization. Moving along, let's talk about redundancy and replication. Redundancy ensures that your data is durable and available even in the event of hardware failures or outages or planned and unplanned events. To ensure data durability, Azure Storage maintains multiple copies of your data. When creating a storage account, you can choose a redundancy option that best suits your needs. While Azure provides various redundancy options, their availability depends on the specific storage service. Blob Storage offers the most redundancy choices, whereas a service like Managed Disks offers limited options. You can choose the redundancy option that best matches your durability, availability, and cost requirements. The available replication options are LRS, that is locally redundant storage. This keeps 3 copies within a single data center in one region. It helps protect your data against server, rack, and drive failures. It's a cost-effective option for non-critical data and is suitable when regional availability is not a priority. Next is ZRS, that is Zone Redundant Storage. In this, data is replicated across availability zones in a single region. ZRS replication protects against data center failures. It is suitable for applications requiring high availability within a region. As best practice, Microsoft recommends using ZRS in the primary region for any Azure Data Lake storage workloads. Then we have GRS, that is Geo-Redundant Storage. GRS provides data replication locally and asynchronously to a secondary region. It ensures data availability in the event of regional outages. So this can be leveraged for critical data requiring disaster recovery across regions. RAGRS is Read Access GRS. It is the same as GRS, but includes read access to the secondary region. It is optimized for workloads needing read redundancy. And then we have GZRS, that is Geo Zone Redundant Storage. This combines zone level redundancy with geo redundancy, replicating data across zones in the primary region and asynchronous replication to a secondary region. GZRS is ideal for mission critical applications. RAGZRS is the same as GZRS with read access to the secondary region. It combines zonal and geo-read capabilities for highly available read redundancy. You can tailor your storage solution to meet specific workload requirements by balancing cost, performance, and availability. By combining performance and redundancy options, such as, say, pairing a performance tier that is standard or premium with a redundancy option, for instance, LRS or GRS, you can create an efficient and resilient solution aligned with your workload needs. Azure Storage performance tiers and redundancy options offer flexibility to support diverse workloads, from cost-effective bulk storage to high performance, highly available enterprise applications. Choosing the right combination ensures an optimal balance between cost, performance, and data resilience. Let's talk about security. Azure Storage provides robust features for data security, access management, secure connectivity, and governance, ensuring that your data is protected, accessible to authorized users, and compliant with organizational policies. We have data encryption at rest. All data in Azure Storage is encrypted by default using Azure Storage Service-Side Encryption, SSE. Microsoft recommends using SSE to protect your data for most scenarios. You can choose between Microsoft managed keys or customer managed keys stored in Azure Key Vault. Then we have data encryption in transit. Azure requires secure transfer to ensure that data transmitted to and from Azure Storage is encrypted using HTTPS. Azure Storage offers features like soft delete for blobs and containers to protect against accidental deletion or modification. It enables you to recover the data after it has been deleted. You can lock your storage account to prevent accidental or malicious deletion or configuration changes. Locking a storage account prevents the account itself from being deleted. Next up is Azure Policy Compliance. Azure Policy provides built-in initiative definitions for compliance domains and security controls related to different standards. This ensures that your storage accounts adhere to organizational and regulatory requirements. Then moving to access controls, we have RBAC, shared access signatures, and access keys to ensure that only authorized users can access your storage components. RBAC allows you to assign fine-grained permissions to users, groups, or service principals. Built-in roles such as storage account contributor or storage blob data reader, they simplify access management for storage. A shared access signature or SAS token provides secure, delegated, time-limited access to resources in your storage account. You can have granular control over how a client can access data. SAS is commonly used for granting temporary access to applications or external users. Storage account access keys provide full access to the storage account data and the ability to generate SAS tokens. It is recommended to use Azure Key Vault to manage and rotate your keys securely. Lastly, on this slide, we talk about firewall and virtual networks. The Azure Storage Firewall allows you to control access based on IP ranges, enabling you to permit or block traffic from specific sources. Private endpoints enable secure connectivity between your Azure Storage account and your VNets via a private IP address. They eliminate exposure to the public internet. As part of network security, you can configure service endpoints to allow secure access from Azure VNets to storage accounts. Implementing these security measures and governance practices help ensure that your data in Azure Storage remains secure, compliant, and accessible only to authorized users. All right, let's move on to the topics of cost and efficiency. Data stored in the cloud grows rapidly, making cost management essential. Optimizing costs and enhancing efficiency in Azure Storage involves strategic planning and the utilization of various features to ensure that your storage solutions are both effective and economical. It involves using the right tools, settings, and practices to manage expenses without compromising performance or availability. Organizing data by access frequency is key to optimizing storage costs. Azure Blob Storage provides multiple access tiers: hot, cool, cold, and archive, designed for different data access patterns. Choosing the appropriate tier based on access frequency and usage patterns can significantly reduce costs. Hot tier is used for frequently accessed data. Cool tier can be used for infrequently accessed data. It helps lower the storage costs. Cold tier has even lower storage cost and is used for rarely accessed data needing fast retrieval. Archive tier is the lowest cost and is for rarely accessed data requiring cost-effective storage with flexible or longer retrieval times. Azure Blob Storage Lifecycle Management provides a rule-based policy to automate transitioning blob data to appropriate access tiers based on specified conditions, or deleting data at the end of its lifecycle. This helps optimize storage costs and ensures efficient data management by aligning storage usage with data access needs. Note that storage capacity limits apply at the account level, allowing flexibility to use one or multiple tiers. As for best practices around tiering, you can store unused append or page blobs, that is, old files, old log files, in cooler tiers for, say, compliance or backup. You can combine small files into larger ones, example zip, before moving to cooler tiers, minimizing the number of operations for data transfer. This will help manage costs better. For predictable workloads, purchasing reserved capacity for blob storage can lead to substantial cost savings compared to pay-as-you-go pricing. This commitment allows you to secure a discounted rate for a specified period. Also, organizing data by retention duration helps optimize storage costs. You can configure retention policies to automatically delete old data that is no longer required. Utilize Azure Advisor's cost optimization recommendations to identify underutilized resources and receive guidance on reducing expenses. Additionally, leverage Azure Cost Management to optimize Azure storage costs by gaining insights, monitoring, and actionable recommendations. Monitor and analyze storage costs, set budgets and alerts, track expenses, identify and clean up unused resources, and so on. You should regularly review your storage utilization and adjust tiers, replication, and capacity as needed to balance performance and cost. By implementing these strategies, you can achieve cost optimization and operational efficiency in your Azure storage solutions, ensuring that your data storage is both effective and economical. For critical applications and processes on Azure, monitoring and alerts is essential. Azure provides a comprehensive suite of tools and features to help you monitor your storage resources effectively. Azure Monitor alerts notify you of specific conditions in your monitoring data, helping you address issues before they impact customers. Azure Monitor collects metrics and logs, offering insights into availability, performance, and resilience while notifying you of issues. Azure Storage Insights, which is part of Azure Monitor, provides a unified view of storage performance, capacity, and availability. As best practice, use Storage Insights to analyze transaction volume and capacity across storage accounts, helping identify low usage accounts to retire. Then storage account diagnostic settings. It enables collection of resource logs and metrics for blob, table, queue, and file storage services. Logs can be sent to Azure Monitor, Log Analytics, or third-party tools for detailed analysis. By utilizing these monitoring tools and following best practices, you can maintain the health, performance, and reliability of your Azure storage services, ensuring they meet your organizational needs effectively. Lastly, here we discuss automation. Azure Storage offers several automation capabilities that streamline storage management, optimize performance, and reduce manual effort. Let's look into some of the key features. You can leverage Azure PowerShell or Azure CLI for scripting and automating data management or configuration tasks. Automate tasks like blob creation, access management, or applying lifecycle management policies, or even create scripts to handle backup. You can create scheduled jobs, do things like monitoring storage capacity and generating alerts for thresholds. You can automate backups with tools like Azure Backup or using custom scripts. As part of storage analytics and monitoring, use Azure Monitor to automate monitoring and alerts. For instance, generate automated reports on storage usage or performance. You can do cost optimization automation. Use Azure Advisor recommendations to automate cost saving measures. You can automate tier transitions for infrequently accessed data using lifecycle management, as we've seen earlier. Use Azure Automation Runbooks to, say, for instance, automate scheduled Azure SQL database backups to a storage account, ensuring secure and accessible regular backups. With Azure Logic apps, you can create and run automated workflows with little to no code involving Azure Storage. For example, trigger notifications when new blobs are added or deleted. Use serverless automation with Azure Functions for event-driven tasks such as automatically processing new blobs uploaded to a storage container, or trigger data processing workflows when files are uploaded. You can automate storage account deployments or configurations using ARM templates, Bicep, Terraform, or other IAC tools to ensure consistent, repeatable setups for storage resources. You can automate security compliance with Azure Policy. For instance, by leveraging Azure policy, you can ensure that data access complies with organizational standards. So you can build an automation around Azure Storage with these tools and more, and manage Azure Storage more effectively, improve efficiency, and reduce operational overhead while ensuring security and performance. All right, with that review of automation, we wrap up this session. To recap, we explored Azure Storage and its core services, delving into performance optimization, cost efficiency, security, monitoring, and automation. Along the way, we discussed key recommendations and best practices to enhance security strategies. By leveraging these capabilities and more, organizations can design secure, scalable, and efficient storage solutions tailored to their unique needs. All right, thanks for watching. I hope this session empowers you to make the most of Azure Storage. Good luck and happy holidays.